Before we begin, there's a link in the description to join the email list. Subscribers receive carefully researched ebooks, detailed videos showing real woodworking projects built step by step, and timber-focused material that isn't published publicly. It's practical, long-form work for those who want a deeper understanding of wood as a material. Now let's get into it. The most persistent myth is that protected wood is wood that has been sealed. Modern construction still operates on a quiet assumption that the best way to protect wood is to block the environment out. Seal the surface, isolate the fibers, and prevent moisture from entering at all. This belief is so common that it often goes unquestioned, even when the evidence around us suggests otherwise. Old timber buildings, bridges, boats, and agricultural structures tell a different story. Many survive not because they were sealed off from the environment, but because they were built with a clear understanding of how wood interacts with it. The myth is not that moisture is harmless. The myth is that moisture is the enemy, rather than time spent unable to escape. Once that distinction is understood, much of modern wood failure starts to make sense. Wood does not decay simply because it gets wet. Wood has been getting wet for as long as trees have existed. Rain, humidity, soil moisture, and condensation are not exceptional events in a timber's life. Decay begins when moisture is held in the wood long enough for biological processes to establish themselves. Fungi that break down wood fibers require sustained moisture levels, oxygen, and time. If moisture arrives and leaves quickly, decay struggles to begin. Old builders understood this intuitively through observation. They didn't aim to keep wood permanently dry. They aimed to make sure it never stayed wet. Modern sealing strategies often do the opposite. They slow the entry of moisture, but they slow its exit even more. When water eventually finds a way in through a crack, fastener hole, or joint, it becomes trapped. The wood remains damp longer than untreated timber would have, and decay accelerates quietly out of sight. Historic builders focused on drying, not exclusion. Traditional timber construction prioritized airflow, drainage, and exposure to moving air and light. Structures were raised off the ground. Joints were detailed to avoid water traps. When coatings were used, they were chosen with drying in mind. Oils, tars, and lime-based washes slowed moisture exchange without stopping it entirely. They aged, wore away, and were reapplied as part of normal maintenance. Protection was seen as a process, not a permanent condition. Sealed wood often performs very well at first. Surfaces look clean, water beads and runs off, early inspections show no visible damage. This reinforces the belief that the system is working. The problem is that most of the critical processes happen slowly and internally. Moisture moves through wood along grain lines and capillary pathways that are invisible from the outside. When drying is restricted, small amounts of water accumulate over long periods. By the time external signs appear, the damage has already progressed. The failure is then attributed to age, poor material quality, or environmental harshness, rather than to the protective strategy itself. Old builders, they expected materials to change and show wear over time. In contrast, modern construction often treats visible change as a failure, even when, honestly, it serves as an early warning. In traditional construction, the ability of a structure to dry was just as important as its ability to resist load. Timber frames, barns, sheds, and dwellings were designed as systems that exchanged air with their surroundings. But nowadays, modern assemblies often rely on layers of impermeable materials stacked together. Each layer may make sense in isolation, but together they create enclosed environments where moisture movement is restricted. Wood caught between these layers is expected to remain stable, despite being denied its natural means of regulation. This expectation, unfortunately, is at odds with how wood actually behaves. Chemical treatment is, all too often, used to compensate for poor design. Pressure-treated lumber and modern preservatives certainly have a role, especially where direct ground contact can't be avoided. But you see, their widespread use has also allowed design decisions that would have been unacceptable to earlier builders. Posts are buried directly in soil instead of being raised. Horizontal surfaces are left flat, rather than shaped to shed water. Structural members are enclosed without ventilation. Chemical protection is expected to overcome environmental realities, rather than work alongside them. Old builders relied on durable species, thoughtful detailing, and separation from moisture sources as their first line of defense. Treatments, when used, were secondary measures. The myth suggests protection can be applied after the fact, but history shows it was designed in from the very beginning. Wood protection was, at one time, inseparable from joinery and form. Protection wasn't something simply applied to wood. It was something achieved through proportion, orientation, and connection. Beams were oriented so the grain would shed water. End grain exposure was minimized or protected by overhangs. Joints were shaped to avoid pockets where moisture could sit. Even tool marks played a role. Hand-planed or hewn surfaces often encouraged water to move off rather than cling. Perfectly smooth, sealed surfaces can actually hold water longer through surface tension, especially once coatings begin to degrade unevenly. These details weren't just decorative traditions, they were practical responses to long-term observation. The cost of believing the myth is delayed, but, well, it's predictable. When wood fails under modern protective systems, it rarely does so dramatically. The process is gradual, fibers weaken, fasteners lose bearing strength, connections soften. Structural capacity is reduced long before collapse or obvious damage occurs. Old structures, by contrast, often reveal their condition clearly. Where is visible, damage is localized. Repairs are possible because the system anticipates intervention. The difference lies not in the intelligence of the builders, but in the assumptions they made about wood. Trees still grow the same way. Wood still responds to moisture and temperature as it always has. Fungal decay still follows the same biological rules. What has changed is how often modern construction ignores these constants in favor of convenience and abstraction. The myth of total exclusion promises control. The reality of wood demands cooperation. Those who work closely with timber over long periods tend to rediscover this truth, often after seeing sealed systems fail in predictable ways. Understanding wood protection is not about rejecting modern materials or returning to a romanticized past. It is about recognizing what wood needs to survive over time and designing with those needs in mind. Old builders did not protect wood by isolating it from the world. They protected it by allowing it to function naturally within it. That knowledge remains relevant whether you are building a structure meant to last decades or one meant to serve in uncertain conditions. Timber rewards those who respect its behavior and quietly punishes those who deny it. If you want more in-depth work like this, including extended explanations and real project observations that don't fit into public videos, you can join the email list using the link in the description. That's where the deeper material is shared. Thanks for spending this time with Old World Timber.